A company is marketing an investment opportunity to four potential customers. The company believes that its probability of making a sale is zero point 0.5 for each of the first three customers and zero point 0.1 for the fourth. The customer's purchases are independent. Calculate the probability that at most two customers purchase the investment. So let X be the number of customers who purchase the investment, or X be the number of purchases. We have to find the probability that at most two purchase, so probability X less than equal to 2. And we can look at it as the complement of X greater than 2. And greater than 2 would mean 3 and 4 in this case, because there are only 4 customers. So as we will see below, this is more convenient to do it through this complement. And so probability X less than equal to 2 equals 1 minus P of 3 minus P of 4. Now, 3 purchases can happen. So basically, we have to find the probability of 3 purchases and 4 purchases. So 3 purchases can happen in the following ways. All the first 3 purchase, while the fourth one does not. And since the purchase probability of the first 3 is 0.5, so this probability would be 0.5, 0.5, 0.5, and then the fourth does not would be 1 minus 0.1, because for the fourth to purchase, the probability is 0.1. So for not purchasing, it would be 1 minus 0.1. And therefore, we get 0.1125. So the other way in which 3 purchases can happen is that 2 of the first 3 purchase and the fourth one also purchases. The probability of that is 3 combination 2, which is like 2 of the first 3 purchasing. And this, you can think of it as binomial, that when we're calculating the 2 of the first 3 purchases, each probability for the first 3 is 0.5. So it's 3 combination 2, 0.5, power 2, 1 minus 0.5, power 3 minus 2. So this first part is binomial. And the fourth purchases, so and means multiplication, and the fourth purchase probability is 0.1. So you time this binomial expression with 0.1 for the fourth one. And the reason why we do the first 3 separate and the fourth separate is that the purchase probability of the first 3 is 0.5 each. And so they can be lumped into a binomial situation, whereas the fourth one has a different probability. So we treat that differently. So all this comes out to be 0.0375. And now you can convince yourself that these are the only 2 cases in which 3 purchases can happen. Either all the first 3 purchase and the fourth doesn't, or 2 of the first 3 purchase and the fourth also purchases. So this probability, second case, is 0.0375. So the total probability of 3 purchases would be the sum of the 2, because it can happen in this way or this way, and or means addition. So P of 3 would then be 0.1125 plus 0.0375, and that's 0.15. So the second thing which we have to evaluate if we look at this expression is P of 4, which is 4 purchases, which means all the 4 purchase. So the first 3 is 0.5, 0.5, 0.5, and the fourth is 0.1. So N means multiplication. Therefore, we have a multiplication in all of this. We are saying first purchases and second purchases and third purchases and fourth purchases. So that's 0.0125. Therefore, equation 1 gives probability X less than equal to 2 equals 1 minus P of 3 minus P of 4. So 1 minus 0.15 minus 0.0125. That's 0.84, and that's choice D.